Hi everyone, good morning. I'm James. I'm used to events a little bit smaller than Strata, and they tend to be very high energy affairs. So I've been asked to come and warm you up a little bit. Who's excited to be here at Strata SF, the PyData track? Well, you can make some noise. You can make a little bit more noise than that. Now, one thing that I like to do whenever I give a talk is I like to do a little call and response. You can guess what the response is going to be. So I'm going to start off and I'm going to say, "Hi, my name is James." I know it's 9 a.m. in the morning, but I'm on New York time, so it's about noon for me. But one more time. Oh, that's even weaker, but I'll let you go. I'll let you go. So I work a lot with finance companies, and one thing that you might notice if you work with people who have ever been in the finance industry is that a really powerful Excel user is a person who uses Excel for everything. And one thing that you may see today is an incredibly gratuitous use of IPython Notebook. This is the mark of a serious PyData data scientist. We use IPython Notebook for everything. So here are a couple of slides that I wanted to prepare to share with you about PyData and about NumFOCUS, all in a Python 3 IPython Notebook, even though there's no code in it. So I'm James Powell. We're at PyData at Strata. It's Tuesday, March 29th. I'm the vice president of NumFOCUS. I wanted to do a couple of things before we get started today. I wanted to introduce our star speakers. We have a full day of tutorials. They're going to be amazing. All of the speakers we have are fantastic, and I just wanted to introduce them to you. So we have TJ who's going to kick us off today. TJ is with Continuum Analytics. He's a developer there. We have Sarah Bird at Aptivate, and Brian Vandeven. He's the core developer of Bouquet at Continuum. We have Katrina Rial, head data scientist from Continuum as well. And we have Jake van der Plas, who leads the eScience Institute at University of Washington. So we've got some really fantastic speakers today. I think you're going to really enjoy yourself and learn a lot about PyData. But before we get started, I wanted to answer two very simple questions for you. What is PyData and what is NumFOCUS? So PyData can be a lot of different things. It's a Twitter handle. It's an open source data science stack. And it's a conference and a global organization. So just starting with the very basic, it's a Twitter handle. So if you're interested in what you see today, and you want to learn more, and you have a very short attention span, limited to about 160 characters, please follow us on Twitter at PyData. I'll be tweeting the events of today, so if you need any materials or you want to show other people at work what you learned here, tell them to go to the PyData Twitter feed, and they'll see all of the events of today. But PyData is a little bit more than that. When people say the word PyData, they often mean this open source data science, business intelligence, data analytics, numeric and scientific computing stack. What that means is a bunch of tools, all of which are free and open source, that can be combined to do some very powerful things in the fields of data analysis, data science, business intelligence, numeric and scientific computing. And I wanted to list a couple, but not exhaustively all of the tools that you might see here today. These tools include NumPy, which is an all-purpose n-dimensional array. It's the underlying tool that a lot of other tools we use today are built upon. You'll probably go through a lot of Pandas training today. It's a data frame tool. If any of you are familiar with R, it provides a lot of convenience mechanisms with which you can manipulate your data. We'll be using Jupyter or IPython Notebook today, which is an interface for interactive, reproducible data science and computing. We may do a little bit of scikit-learn today. It's a machine learning library in Python that's becoming very popular. We'll see a little bit of use of plotting, perhaps using matplotlib, which is a publication quality plotting tool. We'll definitely see a lot of Bouquet today. Bouquet is a beautiful, high-quality, in-browser visualization tool. We probably won't see a lot of SymPy today, but SymPy is a really fancy symbolic mathematics tool. And we may see a little bit of use of SciPy. It's a general scientific computing tool. All of these tools are free and open source, developed by the community. That means the people on stage and also the people in the audience. And they're provided for you to use. They are serious tools of very high caliber. And I think you're going to really enjoy yourself and see how powerful and how comprehensive and robust these tools are. But PyData is more than just those tools. It's also a conference. So if you like what you see here today, please go to pydata.org and please attend one of our events. We have multiple domestic and international events. here's a list of some of the events that we have going on in 2016. PyData conferences are all over the world in every city. They're a little bit smaller than Strata, usually 300 to 350 person events. They are packed with professional data scientists trying to improve their craft and learn from each other. I want to highlight a couple of events that you may be interested in. Of course, we have numerous international events this year. Madrid, Florence, London, Berlin, Cologne, and Paris are coming up. But in the US, we also have an event in Carolinas hosted by IBM. We have an event in DC hosted by Capital One. I think we have a gentleman in our audience who may have been part of that conversation. We'll have an event this year in Chicago. We'll have an event in New York. The dates for these two are not yet known. And we'll have an event in Silicon Valley. If you're interested in that event, please come speak to me. We're looking for an organizing committee. We're looking for speakers. We're looking for people who are interested in being a part of this event. There is also more to PyData than just the conference. There are local chapters. In fact, Silicon Valley has 2 PyData chapters. What I mean by a chapter is what we might informally call a meetup. The 2 PyData chapters are the South Bay chapter, which is just up and coming. I think it was started only a couple of weeks ago, and a long-standing San Francisco PyData chapter. These are small meetups where they meet on roughly a monthly basis, where you can get together and learn more about the tools and network and meet other data scientists who are using open source data science tools. So that brings us to my second question, namely, what is NumFOCUS? And again, very trivially, NumFOCUS is a Twitter account, and it's also a foundation. So if you're interested in more than just PyData, but the entire world of open source scientific computing, the tools that you see here on the screen today, in addition to the tools that you may learn in class today, please follow us on Twitter at NumFOCUS. But what NumFOCUS really is a 501c3 nonprofit. It organizes the PyData chapters and the conferences, but it also fiscally sponsors the projects that you're using today. All of the tools that you use today are free and open source. You do not have to pay for them. You will never have to pay for them. They are built by the community, for the community, and supported by the community. That said, these tools still need some financial support, and NumFOCUS is a foundation through which these tools raise funding in order to support their ongoing governance, sustainability, and development. NumFOCUS is incredibly important to the sustainability of open source, scientific, numeric, and data science packages, the very tools that you use today. If you're interested in learning how you can help support NumFOCUS, either as an organization or an individual, please come find me and speak to me today. So that's all I wanted to share with you today. We're at PyData at Strata. I hope you're all very excited. I know I'm very excited. And I want to hand you off to TJ. And I beg, please give TJ a much warmer welcome than you gave me. So.
Awesome. Oh, yeah, I think we just, I don't know if you give that back to him or. Thanks a lot, James, for coming and doing that. He just barely got into the San Jose area just a couple hours ago. So, and it's such a huge, it's just such an important organization. I really, in my own opinion, as someone who's been doing, before we used the word PyData, there was this thing called NumPy. And, as someone who's been in that world for a little bit of time, I really feel like this year is really the year where we're taking the lid off and letting people understand more about what NumFOCUS is and what it's for and how it helps this community. And being organized as a 501c3 is just a huge help to, it's just a structural entity so that we can take care of and steward these tools that people have built for no financial incentive just because it needed to be done. So it's just a really cool organization. Okay, so I did what I could to kind of triage any kind of issues to get people going. But this is, let me jump to the top of this. What we've got for you in this first block is a 2-hour chunk where we've called it Data Wrangling and Intro to Pandas. And so we're going to be looking at some data sets and looking at this tool called Pandas, which is a great first cut at any kind of data set that comes your way. Many kinds of data are manageable with the Pandas library. So that's pretty much what the focus of this first session is. As James mentioned, a lot of people who use the PyData stack for this kind of exploratory data analysis. We like what was formerly called the IPython notebook. It's been renamed to the Jupyter notebook. And so that's how we're going to be going through this. And so basically, if you want to go through this notebook, as I'm going through it, executing the cells, and then we have a couple of spots with exercises. We'll see how that goes. We'll just take a little bit, and I'll say, okay, this is a question to answer with the data set. Work with it a little bit, and we'll go around and have answer questions or things like that. We've got a few people. James is besides being a great dresser, is a total code ninja and can help you out with any kind of issues. And then, as I mentioned, Katrina, who's one of our instructors later on, can do some kung fu on your IPython session as well, or Jupyter notebook session. I'm still learning. I'm still training to say the right thing. But that's pretty much what we're going to do today. Is I'm gonna take you through Pandas. So, Pete, we had some questions. I'm going to do this session in Python 3, but this notebook will work with Python 2 because we basically do a little kung fu in this first cell to basically make sure that Python 2 can execute these cells as well. So don't really worry about it. Whatever default you have for Anaconda, as long as you can get this Jupyter notebook up and going, I think you'll be all right. So this is my analogy for Pandas. If your data world looks like this, kind of a messy garage. Yeah, James.
Before you get too into it, who are you?
Oh, I'm sorry. Yeah. So, as James said, I'm TJ Alumbaugh. I'm a developer.
Hi, TJ.
Hi, James. He's a stickler on protocol. So I'm a developer at Continuum. We make Anaconda. I work on a little bit of some things like this, tutorials, some classes that we teach and do instruction, and I work on various projects helping our customers with Python-based, kind of PyData-based solutions. Where typically we deal with things like we're going to be showing you here, number crunching, kinds of high computation, large data sets, things like that. So I have bled a lot on Pandas, and my goal here is for you to not bleed on Pandas, because this is the reality of the world, that your data is just a bunch of messy stuff sitting in various places, and I want to convince you that Pandas is like this suite of tools that is there. If you need a screwdriver, if you need a knife, serrated knife, you need to poke a hole in something, you need a bottle opener or whatever. Pandas has all these tools inside of it. So it's the Python data analysis library. Wes McKinney's original author. It's now has a few people who commit. And they take pull requests, so it's because open source. Wes is now over at Cloudera, one of the sponsors of Strata here. This is a nice quote: "High-level building block for doing practical, real-world data analysis in Python." I think that's a nice, succinct statement. Yeah, I think everything's all been said there. I don't want to give you too much of a sales pitch before we actually start doing any work here. And that's the one thing, we're going to spend a good chunk of time on reading and writing. We're going to talk about labeling, how data is labeled and how you can handle labeled data. It works, Pandas is deals with a kind of missing spot in what was formerly a missing spot in the Python data analysis world of dealing with missing data, which is a reality of the real world of data, that sometimes you just don't have a value. For you people who are SQL ninjas, you will find a lot of familiarity here. We're going to map some of your standard SQL ideas into maybe a different syntax. And the main thing is that, Pandas keeps you, I'm saying, Pandas is a real Swiss Army knife, and it keeps you from making your own homemade knives. Because once you learn what Pandas can do, I want to save you the pain of starting to write a whole bunch of Python code to read in data sets when someone else has taken a lot of time and care to solve that problem for you. And so that's really one of my biggest goals today, is to keep people from writing a CSV parser or something like that. So this is kind of my high level. I want to go over the main Pandas data structures, and then I want to talk about how we get data into Pandas, how we get data out of Pandas. Hopefully your fingers are not going to bleed today, but we will be able to do this slicing, dicing, mixing, matching kinds of activities with some data sets. And I've used my best clickbait headline here to entice you with a little example data set we're going to be working with that's over in the financial space. And then I'll have some remarks at the end. So these were the steps that I showed at the beginning. Just the general idea is to get these notebooks and start interacting with them.
Could you repeat the URL for the notebook?
Yes, sure, sorry, yeah. It is right here, github.com/Alumbaugh, which is my GitHub user handle, /strata_data. So I wonder if maybe I would keep that up on, I could do something like this. Oh, that was good. So yeah, so James, that URL is going to be up on the top of the screen the whole time now.
Okay.
Yeah. Okay. Oh, we're doing pretty good. There are two main data structures that we're going to be talking about with Pandas. The first one is called a series. It's a one-dimensional column of data is usually the way we think about it. And then we have a data frame, which is a two-dimensional data structure that is for a table of data. So it's very natural. If you're familiar with working with Excel, there are some very natural mappings between the way to think about an Excel spreadsheet and a Pandas data frame. And a column in Excel sort of some kind of way, the way a series is. This is where we get to the next level, shows a little bit of difference between Excel and Pandas. Series, one-dimensional array of homogeneous data. So this is where, so how many people are familiar with NumPy? Okay, oh, awesome. Okay, so in earlier versions of Pandas, a series was a NumPy array in the inheritance sense. So it descended from a NumPy array. That is no longer true. It's a NumPy-like data structure. But if you think about it in that way, that can give you some good intuition. So for example, a NumPy array, every element is of the same D type, right? The same type, or the whole type system in NumPy. We refer to that type of the elements of a NumPy array as a D type. That is still true of a series. So every element in a Pandas series has the same D type. So a data frame as a collection of Pandas series is this two-dimensional table where it's heterogeneous data. So all the different series stacked up next to each other, each one can have a different D type. So the next level of trying to take, it seems like people have this understanding of a NumPy array. So in a NumPy array, the only way that you can talk about a certain element of a NumPy array is the index, right? The ith element, index 4 starting from 0. In Pandas, that notion is a more full concept, and a series and a data frame both have an index, which is a way of labeling various elements. In a series, it would be a label of a particular element. In a data frame, it's a label for a row. And we're going to look at that a lot at the different kinds of indexes or indices that you can have. Okay, as I mentioned, in earlier versions of Pandas, the series was a NumPy array in the inheritance sense. It inherited from a NumPy array. Now, this is a nice, accurate way to say it. It's built on NumPy. It uses features of NumPy. It plays well with NumPy. In particular, if you are kind of into the NumPy world, the certain data structures in Pandas implement the array interface in NumPy, but it is not in a NumPy array in the inheritance sense anymore. Ufunc operations are supported. That's for speed. Again, I'm not going to go into the details, but if you're a NumPy person, that will let you know that it will do operations quickly at compile time speeds. Yeah, and some of the best place where Pandas really shines is in datetime operations. And so if you have data that has a datetime associated with it and you are thinking about using Python, you should 100% consider using Pandas. And there's also, if you're familiar with Python, a way of essentially compiling a Python-like language into C code. Pandas is compatible with that. We've pretty much said all that. This is I just thought I'd throw in some links here for additional documentation. You can check those out at your leisure. So if you're using Anaconda, you probably already have Pandas installed. So you can skip this step. This would be more for people who are using, I think it'll find that I've already got, yeah. So I'm using Pandas 0.18 because it's brand new. That's not necessary. In fact, I think this notebook will generate some deprecation warnings on me because certain syntax has evolved since this notebook was generated. But anything from 0.16 and above should be fine. Yeah, so that would be a command that would upgrade your Pandas, but I wouldn't worry about it. So let me tell you what's going on right here, actually, because this all looks like a whole bunch of magic if you've never used the Jupyter Notebook. So I am going to start executing code in these cells. So this little thing right here is called a cell. It has a number associated with it. It has input, and then it has output. Typically, this cell is going to contain Python code. I'm going to type Python code and get a Python output. If you want to execute a shell-level command, so this would be something like a Windows command prompt command if you are in the Windows world, or like a bash command if you're Mac or Linux, you just put a bang in front of it, an exclamation point. And then that will execute that command. That will shell out that command. And so if you're familiar with the command prompt, if you like doing things with the Unix command line, the Jupyter Notebook is a nice way to mix and match there. You can do shell operations and whatever, and then go back to Python and so forth. So what I'm doing here is I'm just executing. This actually is a nice. You should be fine if you don't have this package installed, but basically this is a package that's going to go grab some data off the internet for us to do analysis. This is another thing that I find that people who are new to the Jupyter environment find to be really nice. So now that we have Pandas installed and imported, Tab completion is a cool thing about the Jupyter Notebook. So anytime that Jupyter knows about the variable or the name really that you're using, it's like an IDE kind of environment. So you type the name, in this case pandas dot, and then hit tab, and then it'll just give you a list of everything that it knows about that is accessible from that variable, in our case, which is the pandas module. Python programmers are lazy, but we also like namespaces. So instead of importing every single thing from the pandas namespace, and instead of typing pandas dot data frame pandas dot series, we use this little abbreviation. So this is, if you're a NumPy programmer, this is similar to the import NumPy as NP.
Do you suggest we just follow doing what you're doing all over?
Yes, I think that would be a good way to go.
Can you just back up where you did the tab?
Yeah, sure. So let's see. Oh yeah, right here.
What do we select?
So if you hit pandas, if you type pandas dot and then hit tab, press tab.
That's all. We don't have to select any one of those.
No. Yeah, that was just to show you tab completion. Yeah. Sorry, the question was just asking about what was required, or what should you have done at that cell, which I just wanted people to hit tab. Oh, I think I skipped. I'm not sure if oh yes. So I explained this line. So we're going to be referring to all the names inside the pandas namespace as PD. We're going to say PD.dataframe, PD.series. And it's a very similar idiom to NumPy programmers with import NumPy as NP, if you've done that before. The next thing we're going to do is we're going to be making some pictures. And so here's another piece of code that is not pure Python, but this is a Jupyter-specific syntax, and this is what's known as a Jupyter magic, and there are various commands that help make the environment more useful. This one is to basically take matplotlib plots and plot them inside the notebook. So it's %, all Jupyter magics start with a % sign, so % matplotlib space inline, and that will get you ready to go to plot inside your notebook. Oops. So here is where we'll see, if you've started the notebook and downloaded the data, you should be able to read in this, you should be able to execute this command and not get an error message. And so what's happening here is we're reading in a CSV file that's in the data directory of that repository. And the name of the file is goog.csv. And there's some other arguments here we're going to be talking about. And this is just a little intro into this table-like data structure that's called a data frame. And so you'll see that this is organized by date here along the side. It has various columns, so sort of an Excel-like experience. And we'll talk a lot more about how to get in this data structure and what these things are. So it reads data into memory. So there are ways of dealing, with chunked reading, but the typical, a pandas data frame will be resident in memory, and we'll talk about some libraries that have extended that.
Any data type like CSV, SQL?
We'll go over that. Yeah. So the question is, what kinds of data formats are available, and that's part of the tutorial today. Yep, so if you go to, there's a URL at the top here, github.com/tolumbau/strata_data. So if you are, oh yeah, so Katrina's gonna help you out. She's right there, yeah. So here's another way of getting at this data set. Actually, since you have the goog.csv file, you'll probably be okay. So now we can look at the type of what we just made here. And so this is a data frame. Oh, and then that's the tab completion that we've already shown. So now this is our first way of inspecting a data set. So this is almost all the time what you would do if you were reading in some data set that you don't know. So we're going to look at this read CSV command in a little bit more detail. But the bottom line is you're going to have a data frame, and you want to look at what do I have here. And the head command kind of, if you're familiar with the Unix command head, very similar kind of thing. Show me just the first few rows of this table. Well, I need to, oh, that's a typo. I don't is that in yours? Is the E in yours? That shouldn't be in there. Yeah, no, the E was a typo. It shouldn't have been in there, so that was probably my fault. But the general idea is we're going to look, and the default for head is to show you the first 5 entries. And so if you want to see more than that, you can just say, I'd like to see the first 10 entries. Very similar to the Unix command. So the next level, besides just like looking at a few of the rows, might be to look at, I think there was a question here about types or something like that. Oh no, he was asking about data formats. But you might want to know, because I told you that each one of these columns, which is a series, can have a different D type, an underlying data type. Is there a quick way to basically look at the different types of what you've read in? And that's .info. And it's a nice, it'll basically tell you, a little bit of information about the data frame, how many non-null entries, the column names, and then the last element here is the D type of that column. So this is a float64 or an 8-byte floating point number. And for this one, they all have the same. All have the same D type. Oh yeah, and it also tells you its resident size in memory. Okay, so now we get into, I'm going to talk, so I've talked about the different columns here. Now we're going to start talking about that thing that was on the left-hand side, which is what we call the index. So that's this guy. So actually, here's our first syntax showing how to select out one column of a data frame. So when you select out one column of a data frame, you get back a series. So by selecting out the open column of this Google data frame, we get back a series that just has these values. So it's, that's why we think about it as one column of data. And then the index for that data frame follows, you can think of it as kind of following the series, the resulting series. And this is a very long data frame, but so it doesn't show you every single value. It just kind of does this ellipsis thing. It shows you a whole bunch at the beginning and then several at the end. Okay, so now we're going to get more into this in a little bit, but just the general idea of slicing and dicing. I want to look into a piece of that data frame. This is using the iloc accessor on a series. And so I'll just tell you that basically we're looking at the integer index 0 through 5 of this series. But there's also a way of saying, well, I've got dates over here. I mean, every one of these elements has a date associated with it. I would like to slice it by date. And that's called label-based indexing, and we use the loc accessor. So we're going to go over this in more detail, iloc and loc. But that's another way of slicing into the data. We can start filtering data in this way, so we'll go over this syntax in a little bit more. But again, I'm going to pull on your NumPy knowledge. If you're familiar with the idea of selecting out of a NumPy array based on a Boolean flags, this is a similar kind of idea. So in the Google data frame, where close is greater than open, give me a new data frame back, and then show me the first few rows of that. So every single one of these will have, close higher than open. Like I said, Pandas was built. I mean, really, one of the main problems that needed to be solved and why Wes McKinney built it was dealing with missing data. And so this is a nice way of filtering out missing data. So this again if you are from the NumPy world, we're producing a Boolean mask and then indexing the data frame from that.
So we are eliminating the row?
So we're basically creating a new data frame that has all the missing data. However, the Google data frame doesn't go anywhere.
Is it transient or is it permanent? The new data frame that is being created, like it is only for this execution, or we are putting it in the hardware?
So the question was, now that the Google filtered name exists, is it only resident in this cell, or what can I refer to it later on? So in a Jupyter notebook, we now have these we have many names in the namespace, but we have Google filtered, Google underscore filter, and Google. And for the duration of this Jupyter notebook session, until I reassign or remove those names from the namespace, we have those names and they're associated with two separate data frames.
We haven't modified the original.
Correct. And so we have not modified the original Google data frame.
Can we do that?
Yes. Yeah. Sorry. The question was, can we can modify it? We'll be talking about that. So the next level is okay. Well, that's fine. Now I got some basic information about the data frame. What about just some really basic statistics? And there's oh yeah, question. Yeah, so the question is it maybe is there any cleverness going on to prevent a full verbose in-memory copy? And the answer is no, in terms of the data itself. So that data is all copied. And so typically, Pandas access comes back to you. When you do a get item, you're going to get back a copy of the data. Okay, so just a really nice, helpful method to give you some very basic statistics on the data. So here is a way of adding to the Google data frame. So you call a new one into existence just by using this syntax of the bracket syntax. So this is similar if you've used dictionaries in Python. How do I put a new key and value in a dictionary? Bracket, the name, the key I want to use, right? Bracket, equals, and then the value. So what we've done here on the right is executed a method called %change, which is a handy convenience method on a series, right? Because since accessing this is going to give us back a series. So we do %change on that series, and then we write that into a new column of the Google data frame called return. And then we can access that. This is just showing you that NumPy plays nicely with Pandas, so we can do NumPy operations on these series. And the broadcasting feature of NumPy is in effect here. And then we add an additional series to the data frame called log return, or the name of that column is log return. I'm not going to spend too much time on this. The point is just to get you to make this nice little pretty picture. So the idea here is we're just going to make a nice picture of the volatility of this Google stock. Here's the close price, and then here's the volatility, which is based on like trade volume and some other kinds of math in there. It's like a rolling standard deviation of the trade volume. So the idea was there a period of time where all of a sudden a whole bunch more trading happened than some other time within a particular window? So that's kind of the intro of what these data structures are. One-dimensional data is a series. The typical use case is you are dealing with a data frame. There's also, so we have the one-dimensional series. A collection of series is a two-dimensional data frame. You can extend that out. A collection of data frames would be, you can think of it a stack of these two-dimensional data frames. That's called a panel. Sometimes people use those, not that frequently. And hopefully we'll have time to get into, instead of doing that, there are use cases where people want to do that. The typical thing that you see people doing that is they use a hierarchical index to do a similar kind of thing that people would normally do with a panel. This is just some display settings for what we're going to be doing in a minute here. So yeah, so now let's work with some actual real data. How are we doing on time? Let's see. Yeah. This is a data set on the exoplanets, all the known exoplanets up to maybe sort of the end of last year, I think. It's a nice little data set. Here we're just looking at the name of all these different planets. Our curriculum developer is kind of a sciencey guy, so he likes doing that. So now I've shown you twice, like this magical read CSV command, and in comes a CSV, out comes some data frame or whatever. But Pandas interoperates very nicely with pure Python, and so here's a way of making a series just from a Python list. Or if you want to make it out of a dictionary, you can do that, and that gives you where the keys are now going to be the labels for the index, and the values in the dictionary are the actual series values. So now I'm going to tell you, I think this is a very important piece of information. I'll make sure it's high on the slide. Really, almost all the complexity of Pandas and all the stuff that we're going to look at here, nearly all of the complexity is due to this ability in Pandas to index by position, the way that you do with NumPy, 0, 1, 2, 3, 4, or by label, which could be a string, like in this case, or a date time, or other kinds of objects like that. And so because you have that capability, and because the data structure can be labeled in these sometimes complex ways, the syntax gets kind of messy. With NumPy, it's very easy. Like everything has one D type, and it's n-dimensional, but there's very nice, very simple rules for how you deal with scalars versus vector valued quantity, and how you dig into slice and dice that NumPy array the way that you want. With Pandas, there's now two different ways of doing it, and you can mix and match them. So that's really what the heart of the issue is. So when you start digging down, the main thing is we're going to look at some code here, and 2 days later you're going to come back and hopefully try and solve your own problem with this. And you'll look at some things that'll look very strange, and you're like, wait a minute, what's going on here? One of the first questions they ask when you look at someone else's Pandas code or your own Pandas code that you wrote like 2 weeks ago is, am I indexing by position or by label? And and so we'll look at some ways to be very explicit about that. Just some other examples of how you can create series just from native Python data structures, an order dictionary, a NumPy array. Okay, so now I'm going to give you a little bit more detail here. So series.iloc, we looked at it before. This is positional indexing. And the way to think about this is it's an integer location, right? So if I'm looking at a particular integer location, that is NumPy style positional indexing, starting with zero-based indexing, because that's how Python is. So that's what you should think in your mind. Like if I want to do positional indexing, I want to use iloc.
Do we need to initialize a matrix before, or by default it's always initialized to empty or zeros?
So the question is, can I create an empty series, right, or an empty data frame? I don't think you would want to create. So typically what you do is, so let's just do something here. So I don't think it's going to stop you from doing this. Yeah, so you can have an empty one if you want. Okay, so where was I? Right. So here's, so again, now I want to do label-based indexing with loc. There are times when this labeling doesn't have to be unique. So now now we go down deeper into the rabbit hole of now I can basically say, give me the elements at this label, and because we're not doing things like 0, 1, 2, 3, 4, it's just some label. What if there are many elements that have that label? Well, you get all of them back. These things play nicely with the Python iteration style. Although for speed and performance, you typically want to avoid, iterating through every, something that we would try to avoid would be something like a for loop in Python where we iterate over every single element of a series or an element or a row of a data frame. So it's again leveraging that NumPy knowledge. The idea is that you want to do broadcastable operations that sort of operate on everything all at once. So,
apply feature?
Say again?
Do you support apply feature like on every?
Yes, yeah. So the question is there a notion of an apply operation? And there is, and we'll get into that. So now, not only can you grab one particular label out of there, we can do slices, just like with NumPy. So this cell that I'm in right here, cell 43. Is the classic NumPy style slice, start index, colon, end index, and we do not include the end index. So now we get into, this is a great cell to basically make your life more complicated. So my apologies. So we have integer-based or positional indexing and label-based indexing. Positional indexing works the way that you have been trained in NumPy, start index, colon, end index, and not including the end index. Label-based indexing, right? So when we have strings or something like that, is inclusive of the end index. That's just the way the world is here. I don't have any particular reasoning for you there, but that's how it works. So here we have 1 to 2, which ends up with one element, but we have B to C, which are adjacent to each other in the index. We end up with both B and C. Wraparound indexing is supported. Including so this is positional-based indexing with a step size. Yeah, question. So yeah, the question is, what is the ordering of the labels in an index if it's like a string-based index or something? So when at index creation time, which is oftentimes when the series or the data frame comes into existence, there will be a decision made if the index should be sorted or not. If you want it to be sorted, and we have an example of that. But if it's sorted, what'll happen, if it's sorted at creation time, it'll be sorted once and then that's the layout, right? If it's not sorted at creation time, if it's B, A, D, that's just the way it is. Those are the labels. But once that it's assigned, it's saying that's the label for this row if it's a data frame. Right. So if it's BAD, the question is now I'm slicing into a series let's say with strings as the label, but it's not sorted. The strings are not sorted. So it tries to find the first one, right? So you have in the slice, so B, so they B colon D or something. Here, maybe we have it here actually. I think series 2 is not sorted. Well, it has A. Well, it has A down there. Okay. Well, for example, what about this? Yeah. Right. So like that. Right. Oh. What did I do wrong? oh, that's not a unique label, so it will not allow you to do that. Yeah, so if we really wanted to slice in that way, we'd have to do, I mean, we'd have to like do something. Let's see if this, I don't even know if this will work. I don't even, would that work? No. So the bottom line is that it's generally a bad idea to duplicate your labels in this way, but it won't prevent you from doing it. So if we wanted to slice, like, and get D to A there, we probably would do something like, I'd probably just do this and let it go to the end. But sorry, so in terms of what is the mechanism that it's engaged in, right, when it's trying to do that slice operation, it starts at the first one, works its way down, right, to try and find the first part of the slice, then the last part of the slice, and then in this case, the reason why it erred is it said, okay, starting from D, go down and try and find A. Oh no, that's ambiguous. So that was the error message. And then, so if it does find a valid range, then there's the third argument, that, optional argument for a slice, which is the step size, and it will try and obey that step size. Including, and so, yeah, actually, because you can give a negative step size, that range definition could work down the index, or it could go up, right, which is what's happening here. The kind of similar kinds of broadcast operations, arithmetic operations, are all supported.
Let me ask another question.
Yeah.
I'm just wondering, whatever we are doing right now, it is for one user. Like if I am the consumer, I am evaluating, discovering the data something. What if I want to make it like a product, like something that I do something and somebody can use it like a black box?
Why don't we can take that offline, yeah. Because I want to make sure I get to as much of this as I can. So here I'm just showing you, the idea is we make, this, if you have done these kinds of things with NumPy before, the idea is doing a range from negative pi to pi, chopping up into little pieces, then doing the sign of that data and then plotting it. Very typical kind of matplotlib kind of operation. All that plays nicely with pandas. I'm almost at, yes, okay, this is my favorite cell of this little section here. So I want to take a moment here and make sure we understand what's happening. We have this series 1, 2, 3, 4, 5 with this index A, B, C, D, E, and then we have series 2, 10, 20, 30, 40, 50, C, D, E, F, G. And so then we add these together and we end up with this. So let me start by, so that's what series 1 looks like, and that's what series 2 looks like, and we end up with this. So we have not a number, 13, 24, 35, not a number. So I want to, if people are kind of SQL people, I'm kind of asking you what kind of operation just happened there? A join operation, exactly, and it was a particular kind of join where we ended up with a bunch of null values. It's the outer join, right? So this is just an example to say that pandas defaults to outer join, and so that is just a decision that they made where, in other words, when I can match up labels, do the operation. When I can't match up labels, just plop it over and that index will be in the resulting sum in this case, but I don't have a value there. So I just give you not a number. So if I wanted to do, so because it's default, you kind of have to get a little bit fancier if you wanted to do, an inner join. And the way that we would do that is with this concat operator, where we have a series 1, series 2, and then this is where you actually are going to say the join. Oh yeah, that's a nice little feature of the notebook. So now my default is going to be outer, and I'm going to say I want to do an inner join, and that will. Oh, but I didn't get the same numbers. What did I? Oh, series. Did I? Oh, sorry. I think I want merge. No. I think that's right. Yeah. Oh, I'll do that at the break. I thought I remembered. Yeah, I want to concatenate them and then add. Oh. So if I do something like this, I should be able to. Yeah, and then I can add from there, and then I have to do it. Yeah. Sorry about that, but the main point was basically to say that the default is going to be this outer join. Yeah, so this mean is going to intelligently handle nans. Technically, like a NumPy, if you've done NumPy kinds of operations before, when you get a nan, these nans tend to propagate through and mess up all your calculation. Pandas basically says, I kind of know that you don't want me to consider the empty data. So here's our exoplanet data set. Whoops. Oh, I want to skip over that. I had some extra in here. I've got some better. Oh, okay, yeah, this is just basically some more showing you the ways of indexing into these data frames. Similar kind. So before we were showing iterating over series, now we're showing iterating over a data frame. This is actually nice where when I want to iterate over the entire data frame, Pandas has, dictionaries have iter items, data frames have iter rows. So the index will be the first value, and then the second value that comes back with iter row is the entire row. And then here then I'm indexing into that row with a particular column, which is Alice. But if I just wanted to show you the whole row, that doesn't print very nicely, but you get the idea.